Okay, so what do we got? 922. And we are going to be solving. Today we're going to move on and we're going to be solving linear systems algebraically. Solving linear systems algebraically. It kind of means using algebra to solve a system. So, in a system is when you've got a linear system is when you've got more than one equation and you're solving for your variables. All right? So, today it looks like we are going to be solving by a technique called substitution. We're going to be solving by substitution. So, when we are solving by substitution, what is the solution? The question is going to be, what is the solution of the system of equations? And here's our system of equations. We've got 3x plus 4y equals 12. And we've got 2x plus y equals 10. And we need to solve for x and we need to solve for y. Now, when we are solving by substitution, that means we are going to pick one of the equations. We are going to solve for one of the variables. And then we are going to substitute that into the other equation so that we can solve for the other variable. Okay? Here's what I mean. When you're solving by substitution, the first thing you want to do is look at the two equations and see which equation would be the easiest to solve for one of the variables. And when I look at these two equations, this equation right here looks very simple to solve for y, because the y is sitting by itself. And if we were to rewrite this equation here as 2x plus y equals 10, and then subtract 2x from each side, y would be equal to negative 2x plus 10. And immediately we have solved for one of the variables. The y value in this system is equal to negative 2x plus 10. Once you know what the y value is equal to, you go back to the other equation right here, and you substitute where there's a y, you substitute the negative 2x plus 10. So we're going to rewrite this top equation. We've got 3x plus 4. Now, where there's a y, instead of writing the y, we're going to write what y is equal to, which is negative 2x plus 10. And we're going to keep that top equation equal to 12. Now, by doing that substitution method, in the equation now, all we have are x's. And you can solve and get a numeric value for x. Everybody with me so far? Speak up if you're not. Yes. Okay, so once we have substituted what y is equal to into the other equation, we're going to distribute. So we're going to get 3x minus 8x plus 40 equals 12. And then we're going to combine like terms. So 3x minus 8x. 3x minus 8x would be negative 5x. Plus 40 equals 12. If we subtract 40 from each side, then our negative 5x would be equal to 12 minus 40. Negative 28. And then we're going to divide both sides by negative 5. And our x is going to be equal to 5.6. Now you have your x value for this system. In order to get your y value for the system, you take the 5.6, go over here, and substitute the 5.6 where the x is sitting. So you would have y equals negative 2 times your 5.6 plus 10. So the y is equal to 5.6 times 2, negative 11.2 plus 10. So y equals negative 11.2 plus 10 would be negative 1.2. So here's how the solution because the question was, what is the solution of the system of equations? The solution is listed as a point, or the coordinates of a point. The solution is 5.6, negative 1.2. And what that means is that if you were to graph these two equations that we started with on the coordinate plane, they would intersect at this point, 5.6 and negative 1.2. Okay? That is their point of intersection. Does that make sense? It's like, I don't know, 1, 2, like a 4-step problem. Solve for one of the variables first. Substitute that into the other equation. Solve for one variable. Substitute that value to find the other variable. All right, so let's try another one. Here's our system this time. We've got x plus 3y equals 5. Negative 2x minus 4y equals negative 5. So again, we're going to look at the two equations. We're going to determine which one it would be easiest to solve for one variable. And it looks to me like this top equation would be pretty simple to solve for x. So if we rewrite it, we got x plus 3y equals 5, and subtract 3y from each side. Then our x is going to be equal to 5 minus 3y. Now, we rewrite the other equation. And where there's an x, we substitute a 5 minus 3y. So we take negative 2, and where the x is, we put a 5 minus 3y. And then we've got a minus 4y, and that's all equal to negative 5. So we distribute. Negative 2 times 5 is negative 10. And negative 2 times negative 3y would be positive 6y. We bring down the 4y, and we bring down the negative 5. Bless you. Next, we can combine like terms. So our negative 10, we got a positive 6y and a negative 4y. Positive 6y and negative 4y. That's a positive 2y, and that's still equal to negative 5. If we add 10 to each side, we got 2y is equal to 5, and we can divide both sides by 2. So our y is equal to 5 divided by 2 is 2.5. So if you know what your y is equal to, you go back right here to your x equals, and where there's a y, you substitute this 2.5. So our x value is equal to 5 minus 3 times 2.5. You can type that in your calculator. 5 minus 3 times 2.5. And that. What's that? I don't know. I just typed the whole thing in my calculator. I got x equals negative 2.5. 3 times 2.5 would be like negative 7.5, and 5 minus 7.5 would be negative 2.5. So here's your solution. This is where these two lines would intersect if you were to graph them. So the solution for this system is going to be at negative 2.5 and positive 2.5. If you graphed those lines on the coordinate plane, they would intersect right here. Y'all good with that? I don't think we're going to do solving by elimination today. All right, I'm going to give you a couple of problems to practice today. On your own. And then tomorrow we're going to discuss another technique for solving a system of equations. So I haven't had a chance to get to the copy machine, so I'm going to give you 3 of these and I'm just going to have you write them down, okay? All right, so here's your practice for today. I'm going to call this one number 12, and it is x plus 12y equals 68. X equals 8y minus 12. All right, look up here real quick. Do you see this problem, how x is already equal to something? That eliminates the first step, okay? You can go right to substitution, and where there's an x in the top equation, you can substitute your 8y minus 12 and solve for y. All right, we're going to call this one number 15. X plus 6y equals 2. And 5x plus 4y equals 36. And then problem 18. That's r plus s equals negative 12. Four r minus 6s equals positive 12. All right, and when you're done with those and you feel real confident about your answers, check focus for homework. And when you check focus for homework, make sure you got your notes in front of you, because there could be questions on the homework assignment that are right out of the notes. All right, any questions from class? Any questions from the Zoom meeting attendants? All right, I'm going to end this meeting. I'll post these notes to YouTube, and we should be back on a regular schedule tomorrow.